Assalamualaikum warahmatullahi wabarakatuh. This video is for our presentation group assignment Digital Signal Processing DSP. So here are the team members. The first one is Abdul Hafiz bin Ahmad Zaini, Muhammad Helmi bin Azman, Idham Fadli bin Mat Isa, and last one Muhammad Danish bin Khairul Hisham. So for this assignment, we choose Introduction to Signal Analysis from Lab 1. Alright, so okay, what is signal? Signal is a variable that carries or contains some kind of information which is able to convey, display. By the way, convey means sending, displayed, or even manipulated. Pressure, temperature, speed signal, electric signal, namely voltage and current, are the examples of signal. Meanwhile, Yt, Vt are the dependent variables and T is independent variable. Also, signal can vary with distance, frequency, time and space. So there are two types of signal. First one is continuous time signal, or we call it as CT. If xt can be represented as a real number, a signal is continuous time, and also this continuous time signal has a period and non-periodic. So second one is discrete time signal, or we call it DT. If x and can be represented as a real number, a signal is discrete time. So it is same with the continuous time signal, which is discrete time signal has a periodic and non-periodic. So what is meant by digital signal? A digital signal is one that expresses data as a series of discrete values. It can only take on one of a limited number of values at any one moment. An analog signal, on the other hand, conveys continuous value. It represents a real number within a continuous range of values at any one moment. So for digital signal processing, the concepts, algorithm and procedures used to modify these signals after they have been transformed to digital form are referred to as digital signal processing, DSP. The representation of signals using numerical or symbolic sequences, as well as the processing of these sequences, manipulation of discretized and quantized or naturally digital signals using mathematics and algorithm to extract the most relevant and pertinent information conveyed by the signal. Signals are represented digitally, and digital processors are used to analyze, change, or extract information from them. So here are the characteristics of system. A. The stability. Finite integral of function means system is stable, but if the integral function is infinite, it means system is unstable. For B. Causal. If the current output is dependent on previous or current input but not future inputs, the system is causal. When the input value is less than 0, it produces only zeros. It starts at or after the value 0. So for the example is Yt equal to xt minus 4xt minus 1 minus 8xt minus 2. Okay, this is example for causal. Okay, the below yt equal to xt plus 4xt plus 1 plus 8xt minus 2, and this is not causal. Okay, so C, shift invariant. If a system shifting does not vary over time, it is said to be shift invariant, which is mean similar to invariant in time. Okay, so D, linearity. Okay, so okay, if a system possesses the features of superposition and scaling, it is said to be linear. Okay, so if we apply yt equal to xt plus xt minus 1, the output will be xt equal axt. So it is same if we multiply with constant a, whereas we will get to axt plus xat minus 1. Okay, so E, the linear time invariant, or we call it as LTI. Linearity implies that operation of a system can be scaled to arbitrarily large magnitudes. It has the superposition and scaling properties. Yeah, so egging effects which may affect the outputs of analog system over time violate time invariance. The outcome is independent of the time at which the input is applied. Last but not least, time invariant. A system is time invariant if it does not change over time. The output of a system is considered to be time invariant if it does not rely on time explicitly. If yt is the output of input xt, then yt minus t capital is the output of input xt minus t capital. Okay. That's all for introduction. Next will be represented by next other team members.
Okay, Assalamualaikum. My name is Muhammad Danish bin Khairul Hisham. As for today, or for my part, I will explain this lab simulation. The original part, which is I take this part, basic signal operations in time domain. Okay, so let me pick this subs question or sub exercise. Okay, so what I will show or simulate is write a complete code to use the function convolution to generate the convolution between function Sn and Hn. Sn is rectangular signals and Hn is sync signals respectively. Okay, so what we need to do is we need to come out the output for rectangular signal and sync signal and convolve both of them become one output or one signal, which is yn or whatsoever. Okay, so without further ado, let's try run it. Okay, so the rectangular signal coding, sync signal coding, and the convolution between it. Okay, so let's run this coding. Okay, so we can see this is the output for the coding. So we can see the rectangular signal and the sync signal. So we can see the unit samples is 20 and this also 20, and when it convolve together or combine together it will become 40. So convolution is the combination of two functions, which is Sn and Hn, and become one output. So the convolution process is for the theory part. So for example, we need to calculate it manually. So we need to flip one of the functions. For example, we need to flip hn. We need to flip the the signals, the value of the signals, and we need to time shift it, and for the result it will become like this, the convolution signal output. So we can see it already combined together. Okay, so let's jump to the next question or next exercise. So next is we need to convolve for the output unit impulse signals and sync signals. And let's see, we got here. So we have unit sample sequence signals and sync signal. So we combine these both of these signals and become one. So this is the results. So as we know that unit sample sequence is uh, the x-axis. If x-axis is 0, the y-axis will be 1, and other than that will be 0. Other than 0, the y-axis will be 0. So so we can see the time shifted a bit, and the signals is also a little bit flip and so on. So the last part is a little bit interesting. So just now we only convolve the uh, what we call the time domain or the signals. So right now we need to convolve a sound or audio, which is uh, a hall situation or hall surrounding, and a man, a talking man in a hall. So we need to combine a man sound, a man voice, and a hall. So we need to combine those two frequency or signal together and come out the what is the output. Okay, so and we also need to try in different frequency, and let's see about it. So this is the basically is decoding for the task. Okay, so for the hall is we need to have this wave type of file, and then okay, so I need to change this to what 100 11250 11250. So we need to use this frequency first. Let's see what is the output. 1250. Okay. Okay, so you can hear the voice is uh, unrecognizable, which is we can hear properly or we can understand what is the sound. So that is for the 112,050 hertz for the frequency. So we need to increase a bit. Okay, so next we need to change this frequency to 2500. Okay, so change this to 22500, 22500, 22500. So let's run this. So we can hear more clear a bit, but still we don't understand what is this man talking about. So last, we just make this frequency. The last one is 441,000. 441,000. And let's see the output.
Le jeu n'est point un amusement d'homme riche, il est la ressource d'un désœuvré. Le jeu n'est point un amusement d'homme riche, il est la ressource d'un désœuvré.
Okay, so we already hear loud and clear. So the first voice is the voice of the man before we convolve with the hall. So the second voice is when the voice of the man and the whole surrounding is combined together and become one output. So this is the graph when it convolve, and so I can conclude that the higher the frequency, the higher the frequency, the faster the volume, uh, the faster the voice will be go for the output. Mm. So the lower the frequency, the slower the audio will play. So that's all from me. Thank you.
Assalamualaikum. My name is Hidam Fadli bin Maiter. I will present the application of the convolution. Okay, firstly is the digital signal processing. In digital image processing, convolution filtering play an important role in many important algorithms in edge detection on and related process. In optic and out of focus photograph is a convolution of the sharp image with lens function. The photographic term for this is bokeh in image processing applications such as adding blurring. Okay, I will show you the coding for the from the original image to the blur image. Okay, this is the I am read for the first line, which is I will attach the original image, and this for the line 2, which is I for the original image. 50 is the sigma. Okay, the value of the sigma. Okay, this is the result, which is I set the image for the 50 sigma, and this is the original object. Next is in digital data processing. In analytical chemistry, stability Golay smoothing filter are used for the analysis of spectroscopic data. They can improve signal to noise ratio with minimal distortion of the spectra. In statistics, a weight moving average is a convolution. Okay, next is the in-acoustic. Reverberation is the convolution of the original sound with source from the object surrounding the sound source. In digital signal processing, convolution is used to map the impulse response of the real room on a digital audio signal. In electronic music, convolution is the imposition of a spectral rhythm structure on a sound. Often this envelopes or structure is taken from another sound. The convolution of two signals is the filtering of one through the other. Okay, for the lastly is the electrical engineering. The convolution of one function with central function gives the output of the linear time variant system, which is called LTI. At any given moment, the output is an accumulated effect of all the prior value of the input function with the most recent value typically having the most influence. The impulse response function provides the factor as a function of the elapsed time since each input value occurs. Okay, that's all from me. Thank you.
Yeah, Assalamualaikum. My name is Muhammad Helmi Azman. Now we have reached to the last part in this presentation, which is the conclusion part. After we demonstrate the demo in the MATLAB, we're able to apply a basic signal operation in time domain and the convolution. For the time domain, we can see the usage of the s underscore m function to mix the two type of signal. And for the convolution, we're able to mix two type of sound. And then we get output after we mix by use this function. We also can increase the value of the frequency to make the output of the convolution will be more clear compared to the lowest value of frequency. And the last one, we're able to define the application of digital signal. As Ilham said before, in the example is digital image processing. We can see from the clear image can be a blur picture. That's the one of the application of digital signal. And the last one in analytical chemistry, we can see how they use this digital signal to improve the signal with minimum of distortion. Okay, I think that's all from our group for this presentation. Thank you for watching.